Alright, ladies and gentlemen, this lecture will cover air masses, fronts, and pressure. There are four different types of air masses, four basic ones. There's continental air masses, those are dry air masses, maritime, moist air, polar, cold, tropical, warm. And we can combine these two. Continental polar, abbreviated lowercase c, capital P. Don't ask me why, I don't know. Dry and cold. Continental polar, dry and cold. These can originate over central Canada. Continental tropical, lowercase c, capital T. These are dry and warm. These will come over the desert regions, the desert southwest, like New Mexico and Arizona. Maritime polar, lowercase m, capital P. They're wet and cold. Maritime polar comes from like the northern Atlantic and the northern Pacific. And maritime tropical, lowercase m, capital T. These are moist and warm air masses coming from the Gulf of Mexico and the Atlantic off of Florida, Caribbean also. So again, CP from Canada, CT from the Southwest, MP air masses from the Northern Pacific and Northern Atlantic, and MT from the Gulf of Mexico. So these will be important. These air masses are going to be important when we talk about fronts, cold fronts and warm fronts. So pressure, atmospheric pressure is a force exerted by the weight of air on surfaces. Again, standard sea level pressure is about 1,013 millibars. Rising air is associated with low pressure, sinking air with high pressure. And when it does that, when high pressure, as it spins counterclockwise, it's spinning counterclockwise and outward. Low pressure will spin counterclockwise and winds will be drawn inward. So it's sort of like this. Low pressure here at the surface, the winds are being drawn inward, forced up. High pressure, sinking air, spreading outward towards other low pressure. Notice here, pressure generally flows from high to low. So when we talk about fronts, we're going to have warm air. This could be a maritime, in this case it would probably be a maritime tropical air mass. This would be a continental polar air mass. Look at the wind directions right here. Winds are out of the southwest at about 20 knots. 20 knots behind the cold front at the surface here. Cold fronts are right there. And out of the northwest. Look at the temperature difference. 50 degrees ahead of the cold front, 30s, 40s, 20s behind the cold front. Look at this is a cross section of the atmosphere. Notice the slope of the cold front. Cold fronts are pretty steep. Frontal lifting occurs, forcing air to rise rapidly. Get a lot of convection occurring. Cumulonimbus clouds, strong thunderstorms generally occur along cold fronts. Behind it, we can have fair weather cumulus clouds. That's what these are. This is what we had yesterday on Tuesday. We had a lot of fair weather cumulus clouds form. You have cirrus clouds. These are cirrostratus here, cirrus, altocumulus, cumulonimbus clouds here as well. So again, ahead of the cold front, we got winds out of the southwest going. Oops, didn't mean to do that. Sorry. So going that way, and winds out of the northwest generally behind it. Triangles. This is note. Star this. Write it down. Triangles are pointed in the direction cold air is moving. Warm fronts, on the other hand, you have warm air. This could be maritime tropical. Whoops. Maritime tropical behind the warm front. Continental polar ahead of it. Not as steep a slope as a cold front. Usually have just a kind of gradual descending rate of cloud decks, starting with cirrus, cirrostratus, altostratus, nimbostratus, and stratus. Behind it, we have, again, our fair weather cumulus clouds. Cold ahead of it, we can have large areas of cold rain and possibly, in this case, snow. 50 degrees behind it. I've seen it. I mean, it's not uncommon to have a 30-degree difference between on either side of the fronts. So again, warm fronts, southerly winds behind a warm front. It's like what we had on Monday. Easterly winds, southeasterly winds, cold air ahead of the warm front. Both of these make up a mid-latitude cyclone. The low is situated between the cold and warm front, and this can develop severe weather. This is what a typical mid-latitude cyclone could look like. This is sort of what we saw yesterday during the bell ringer warm-up part of class. You can see this very easily. Here's the central area of low pressure right here. Cold front extending down to the south and warm front extending to the north. This area here, this area, all this right here, that's called the dry slot. It's an area of very dry air being pulled into the mid-latitude cyclone. When that happens, the storm will die off and move on. So again, this could be maritime tropical air mass. This could be continental polar air mass. Warm, cold, moist, dry. And I think that's all I got on that one. On pressure and fronts is really quick. The whole reason why we're doing this now is so we can put some contours on the map. You will be getting maps like this with a bunch of numbers on it. This will be pressure, atmospheric pressure in millibars. These are just some random numbers I threw on the map, and I'm going to show you how to contour it. There are a couple of different ways to do it. I'm going to show you one way. Whenever I was doing this in college, I always started with the lowest number. The lowest number on here is 996. So I'm going to draw a line through 996. It's the only number we have that's the lowest. There's higher numbers surrounding it. So I just draw a circle around it. I'm going to use a 2 millibar contour interval and go up from there. 998 is next. Watch what I do here. 998 will look something like that. Okay. Next is 1,000. 1,000 will look something like this. Go to the right of the 999. And I always like to label my lines like this, just so I can keep track and keep myself organized. Notice I did not take these are isobar lines of equal atmospheric pressure. I did not extend them past the border of the map. Please do not do that. It makes it, if you do it, it makes for a very messy map. Just keep everything within the border of the map. Next up is 1,002. 1,002 will look like this. 1,002 over here, and up like that. This is 1,002, 1,002. 1,004, there's no 1,004s on the East Coast, so we're done with that side of the map. 1,004 can look like this. And I'm just going to put, for time's sake, I'm just going to put 04. 04. 1,006, look like this. 06. Oops. 06. There's no 1,008 listed here, but we have to account for it. So you put just a random line. I think it's going to be right there. And that's all there is to it. Now what you're going to want to do is also label the fronts and the pressures. Low pressure is here. That's the lowest number on the map with the associated warm fronts and cold fronts. Cold front will be extended. Notice there's these little kind of divots or sharp points in the contour lines. That's typically where the fronts will be, so I'm going to put a cold front here. Triangles on a cold front. It is blue Low pressures are red along with warm fronts. Semicircles will look like that. That's all there is to it as far as contouring atmospheric pressure on a weather map. We will do a lot more practice with this over the next week. Be ready for class tomorrow to do some contouring and start analyzing weather.